Good evening. My name is Tatiana. I'm a software engineer. I have around 20 years of experience. I started working for the Ministry of Science and Technology back in Brazil, developing three-dimensional medical image reconstruction. And then I worked for the TV channel Global, which is the major Latin American TV channel. I moved to the UK. I worked for education, developing educational apps, mostly on the back end. And then since then, I joined the BBC for 4 years or 5. And then last year, I joined Astronomer, where we're building an orchestration platform, which happens to be open source, and it's called Airflow. So during the university, I studied computer engineering. One of the things that most intrigued me by then was the Turing test, if we would ever be able to have some computer behaving as if it was a human and having someone talking to that computer through a command line and realizing, doubting, not being sure if the person or creature they were interacting with was a computer or a human being. And by the time there were some things, of course, there was AI. There was, I remember in Emacs, we had Elisa, the psychological therapist that you could interact. But things were not very good. And it's quite impressive to see ChatGPT right now and how much we managed to develop the large language models. Before we go this way, how many people here are familiar with Apache Airflow? Could you raise your hands? Okay, so we have around 20 people. How many people here have knowledge on dealing with large language models and developing machine learning and so on? Okay, so around 15 people. Okay, so I'm more on the software engineering side, data engineering. I won't be adding that much on the language, on the AI side by itself, but I will try to illustrate how we can use Airflow to try to train these types of models and other things. So when ChatGPT was released, it was quite interesting. Who hasn't tested ChatGPT here? Okay, so that one, we have 100%. So I don't need to talk much about that. But the capability has of building source code and just answering questions and so on. It was really impressive, and it just passed the Turing test. And then I started seeing lots of people actually trying to break and trick ChatGPT, as opposed to using it for career and business progression. And including this one, this came from Reddit, so it may not be real, and it's sort of sexist. I don't know if it's compliant with the code of conduct, but hopefully it's okay. So it's basically, yes, it's a joke where ChatGPT would be biased. And this is something we can expect from any machine learning algorithm, right? So depending on the data, depending on how it's trained, there will always be issues. But I did try to run this question today, and it no longer replied that for jokes about women. So ChatGPT currently does have jokes about women as well. And then I think what we realize with ChatGPT is that each time computers are being able to interact closer to what human beings would from an interaction perspective and text. So about ChatGPT, I don't know how many people know, it was developed by OpenAI. It is a proprietary machine learning model, which means we don't have full control of how it was trained, what exact data was used. When it gives us answers, we don't really know where the data came from. It was fine-tuned from another model, so it's not like it came from nowhere and this genius invented it. It is part of a huger process of development of large language models. At the moment, there are more than 100 million people registered to use it. So you guys are a percentage of that. And it was trained with quite a lot of data. And some estimates say it costs around 3 million to run it per month. But I don't think that's accurate. So, because this particular check, I don't think it took into account fine-tuning and training as well. But this gives some ideas of how massive it is, and there are the references as well. I will be sharing these slides after. So a large language model is a type of AI algorithm trained on a huge amounts of data that can understand and generate text. There are 4 parameters which usually matter: the size of the training set, cost of training, the size of the model, and performance after training. This is an evolutionary tree, and probably as we speak, more nodes are being added to this. So each of these edges represent a large language model that was implemented. The ones which have a colored background are open source models. The ones which don't are proprietary models. And this thing just keeps growing. It feels each day there are more iterations and more things advancing there. There are some limitations with ChatGPT and the other proprietary models. One of them is data privacy and security. So let's say you would like to use it, but you work for a bank which has very strict restrictions, then you shouldn't be posting questions with code that's specific to your company. You also usually can't customize it a lot. You can't be really, you are dependent upon who's building it. The cost and scalability you don't control, so you have to pay always proportionally to the value that you're being charged by the provider. And access and availability, again, let's say you're in the EU, you would like to use some personal information there, but the servers may be in the US, so you may have GDPR complications and not be able to use it. There are several open source large language model alternatives. These are some of them, and many of them are built on top of each other. So we have Llama from Meta, Alpaca from Stanford. So they were trying to get alpaca-like creatures from Peru and Bolivia. And then I think they just gave up because there weren't enough species, and then we ended up to Dolly. So, and then people just became creative. And recently I came across this H2O GPT, which I found very promising. So as most of these language models, it is actually a fine-tuning on top of an existing model, so they are iterating over each other. And it seems this company has a very nice strategy of partnering with other companies and things, and they release things as open source. All their models can be found on Hugging Face, which is super cool. So my original plan for this talk was to show how we could train the H2O GPT model using Apache Airflow. But my demo failed while I was preparing. I didn't have lots of time for it. So, but here you have the material about H2O GPT, and there's an awesome talk, which I think lasts 15 minutes. Again, I will be sharing this on Twitter and with the organizers. And basically, like with 3 commands in Linux or Mac, you can just hypertune an existing LLM model and then spin up an interface, which is just similar to ChatGPT, all based on open source. And you have full control of the data, and you can hypertune it, adding additional documents, so you can start answering questions that it wasn't before. The good thing is they support both GPUs and also CPUs. GPUs will be a bit quicker, as expected, but they support both, which is super awesome. So this was an example of question I asked, what is AI camp? And then it even allows you in the UI to compare with multiple models, and you can add your custom models and things. So it's really cool. And even in the interface, you could already add some documents, and then you can just add in multiple formats and then have it answering specific questions it wasn't before. So if you have a chance, I do think this is a really worth open source project in the area, which I think will grow really well. And the principle is that they have a basic model. So the model they are based on, they are on top of Llama, but there is another model in between. And then they basically fine-tuned it, making it more adequate for chatting functionalities. Apache Airflow. So 20 of you know what Apache Airflow is, but the rest don't. So Apache Airflow is another open source tool, which is used for orchestrating data and scheduling. It is based on batch processing. And then you can set either times on the week, how often you would like things to run, or you can trigger workflows depending on data changes on other workflows. It is used worldwide, so we have around 400,000 downloads per month, per day. So it is heavily used by the community. We have over 3,000 stars on GitHub, and we have a very active development community. Astronomer, we're responsible for more or less 40% of the commits of the project. So it's one of the major contributors of the project. The idea is you define a pipeline. This could be really anything. So you could, for instance, have a task to scrap web pages from airlines companies, and then have another task which tries to fetch some specific flights with source and destination, and then you would like to send an alert to an email. So you can really build any sort of pipeline, data processing, image processing, anything you feel like. This is an example what you may want to do in AI. You could import data, you could clean, transform, and then you could want to train multiple models, pick one of them, and then deploy the model. In Airflow, this whole thing is a DAG, a direct acyclic graph, so we cannot have cycles considering the direction. This is not a cycle because they are pointing forward. We have directions because one task is dependent to the other one. And the other important thing on the basic Airflow UI is these boxes are not data sets. These boxes are tasks. And this can be a bit confusing because you can have a task that generates multiple data sets, and it may not be trivial to see the relation between multiple data sets. So the arrows are dependencies between tasks, and then the edges, the boxes, are tasks. All these names here, which I suppose not everyone will be able to read, even if you wanted to, but all these are providers. So with Airflow, you can have several operators, so tasks can be instances of operators, and operators, there are lots of operators ready. Let's say you would like to download files from GCS, you would like to interact with BigQuery, you want to trigger a data Spark job, or you would like to use Dataflow on GCP, or you want to run queries on BigQuery. So Redshift, if you want to use Azure Blob Storage, there are lots of operators which already offer those features. And then your work sometimes is really try to find out where are the things. You have Elasticsearch, even Facebook and Google APIs, GitHub. So you can try to find whatever is ready there and see if you can use ready-to-use operators, which really speed up the development of many pipelines. This is an example of a very simple pipeline. So how are people familiar with Python here? Oh, okay, so, okay. But so these are importing statements, we're importing modules. This is just a function, it's not doing anything, it's just illustrating. Let's assume we had the logic to train here. This is a DAG, so here is where we instantiate the workflow. And then we have some properties, we have a name for our workflow, when it should start, how often it should run. And then we can instantiate one or multiple operators. This is a Python operator where we would be running this Python function, but we can have tasks of all sorts to interact with all systems. This particular example isn't using pandas, but we could use. So if we wanted to extend it, we could just have it here. So yes, you could import anything. It's just a Python program. So this is a more sophisticated example. So here we have the DAG definition is here. So the workflow is defined here. We're instantiating 1, 2, 3 tasks. So we have, first we have evaluating a model A, evaluating a model B, and then we choose the best model. This is a very simple example. And this is how it looks in Airflow. So for those not familiar with Airflow, this is Airflow, nice to meet you. And then you can see the tasks, you can see the grid. These were times the tasks failed. You can see which executions it failed. You could check the log to understand why things are failing. You can set alerts, so you could be notified if things succeed or fail. You can have a view of all your things. You can also instantiate data sets to see how the concepts within the DAGs relate. So it's very sophisticated. And we know it was built originally as a data engineering tool, and we would love feedback from anyone from the data science area to make it even better for people who work with data science. So if you have any feedback, any idea, please reach out. This is an example of a pipeline I wrote for production, processing metadata from the BBC. This is another example of production pipeline I actually use for training models, also in production using Airflow. This is a much more complicated pipeline which we use to pre-compute recommendations in one specific case. So how does Airflow and ChatGPT or this open source alternative can be glued together? So why would we want to use Airflow together with one of those tools, one of the open source large language models? So we wouldn't be locked in with one provider. So Google, for instance, has amazing tools. There is the AI platform, which has been renamed 4 or 5 times, Vertex AI, and I don't know, I just got lost. And some of those tools are really amazing, but then it may mean that if you wanted to run the same code on other cloud providers, you may not be able to. So to use open source would give you this flexibility. To use Airflow would allow you to have both ETL pipelines and also machine learning pipelines using the same tool. That's what we had at the BBC when I worked there. With Airflow, we can monitor parts of the model pipeline building. It automatically can retry on failures if we want to, can send notifications. We can dynamically trigger tasks using different hyperparameters. We can select models or have branches and decisions as part of the topology of the graph. And it's quite easy to trigger jobs from Airflow to anywhere. So you could say, please run this job on Kubernetes, run this job on a specific on compute engine in the case of GCP. And then in the case of doing large language models on Airflow, I think I have 3 or 4 advices. One of them is use Kubernetes pod operator if you have a Kubernetes cluster. If you're using GCP, there is the GKE pod operator, which has some more Google-specific things. But some of the things you could do is, let's say in the Kubernetes cluster, you have a node pool which has GPU, and you would like to benefit from that. So you can have node selectors, which would make the jobs you're triggering from Airflow and Kubernetes to run on pods which are associated to GPU VMs. If, for instance, you want to have multiple tasks processing the same models and the models are 5 gigabytes or even larger, you probably don't want to be copying them from object store all the time because that actually can take quite a while. I remember sometimes having models which are 2 gigabytes on VMs on GCP, taking like 1 minute to copy to the VM. And that can be a bit annoying. So if you use, for instance, something like NFS or a managed NFS, and you can mount volume on Kubernetes, you can have multiple pods accessing that data without the delay of downloading. Another thing is we can schedule things based on other tasks. So let's say you had multiple workflows and they just keep growing. And let's say you wanted to trigger this workflow, not based on the date, but if other data became available. So you can use Airflow sensors, depending on how you're doing that. But recently it was introduced the concept of a data set. So tasks can have outlets of data sets, and then other DAGs can be triggered by those data sets. So this can be very convenient. Another thing that Airflow offers, newer versions, is dynamic task mapping. So you can, as part of the DAG, dynamically create new tasks depending on the result of previous tasks. And this is super powerful. Some people may say you could already do that even in Airflow 1. But the thing is, you can't add much logic to the DAG building process because that's in the scheduler. And if you have DAGs which are very slow to build, it may affect the scheduler performance and the scheduling of other tasks. So this is how we encourage doing, this is using another way of programming workflows in Airflow, using TaskFlow API. So you don't have to instantiate a class, an operator. You use the decorator task, and then you just add the Python function, and that will be a task in Airflow. And then in this case, it is a sort of MapReduce. So we're saying evaluate model. So we want to apply this function, this task, expand into all the values we have over there. And then after that, we're saying all the output from these tasks, these 3 tasks, we want to pass to the single function, which would choose a model. It's almost over. So regarding the Apache Airflow community, there are a couple of links. So the community is super welcoming for anyone who wants to participate, make questions, contribute. That's the GitHub. And we do have an Apache Airflow meetup. And I think we have lots to learn in our meetup with the guys from AI Camp and also the GDG meetup. We're going to have an event in Canada. So if you happen to be around Toronto in September 19 this year, yes, you're more than welcome to join. We will have some brilliant talks from people who use Airflow and who develop. Yes, Astronomer, we really love the interaction with the community, and we would love feedback on Airflow and how to improve things. The way our main business is a hosted version of Airflow, which can be used in any cloud, any of the major cloud providers. Thank you very much. That's my Twitter handler. I will posting the slides there. And thank you for the organization. It was a pleasure. If you have any questions, please go for it.
Thank you, Tatiana. So that was great. Question times. Yes.
I saw the reference to MapReduce, okay, and that comes from my Hadoop days, okay. Those have been now replaced by Spark. How do you account for that? I noticed a reference to MapReduce for big data. How do you answer that in the place of Spark at the moment?
This MapReduce is a bit more naive than the Spark one. So if you want to use trigger Spark jobs from Airflow, you can use just operators and they will be triggered in Spark, and then Spark will be doing the MapReduce as it does. The MapReduce we have there is just the idea of you have a bunch of, based on some variables, you can spawn multiple tasks, and you can then have a single task processing the output of multiple tasks. So it's not really the big data MapReduce, it's more a fan out, fan in. It's from this perspective.
Thank you very much for the talk. Just a question, you said Astronomer contribute like 40% to Airflow. Is it mostly issue fixes, or are there big things, big projects in the pipeline that you're working on? Thank you.
Astronomer contributed to some big features of Airflow. So until 2 years ago, Airflow was not highly available just because the scheduler, you couldn't have more than one scheduler. So one of the developers of Astronomer, Ash, is a PMC of Airflow. He was the one who implemented that. The data sets feature was implemented by Astronomer. The task mapping was implemented by Astronomer. Many of the providers were originally implemented by Astronomer, or we maintain. Astronomer is also responsible for the releases and making sure they have quality. So all the release process and everything, it is really a nightmare. And initially, I think the guys told me it would take like 1 or 2 weeks to be able to do the whole thing. So Astronomer has been automating as much as possible. And there are more features coming. So Yes, that's a good question. Check out on our next meetup on Airflow. We will be sharing with you, and there will be someone speaking about that. Thank you.
Was one there?
You can try. Thanks. Yeah, so I was kind of thinking about, from a data science perspective, one of the things we care about when we're building models is kind of tracking the parameters that we're using and attaching that metadata to the actual model that we create at the end of it. And we might do like a number of iterations, a number of experiments that produce a number of different models, each with different kind of data sets or tuning parameters, etc. How do you feel sort of Airflow supports that kind of experimental framework and tracking parameters and making sure we're attaching the metadata to the models we're creating?
I think there is lots of room for improvement. So the way you could track at the moment, let's say you're using tasks, let's say a Kubernetes operator, and then you pass the parameters as arguments to that Kubernetes operator. In that case, you would be able to visualize them in the UI. So you would be able to see for a specific run, what was the parameter. But if you wanted to see the parameters across multiple runs, you would probably have to do a query on the database or customize somehow. You can, of course, develop plugins for Airflow, but if we can make this experience better, one possibility we could have is to attach metadata to the data set itself, and then allowing users to visualize that on tables or in a more convenient way. If you think this would be a good feature, we can probably work together, and in the worst case, we can log a ticket for the community, and if Astronomer can't develop, at least we have awareness, and then we can move forward in that direction.
I go. It's my time for quality. No. Here.
Thank you very much. I really like Airflow, and I've looked at Astronomer a couple of times from a commercial perspective of did we want to use Astronomer, but we never quite got over the line. So when you're contributing back features to Airflow, which is open source, or developing features for Astronomer, which is less open source, how do you decide when your development efforts are going to be open sourced or they're going to remain a selling product? And how do you maintain having a unique selling product that people actually want to buy Astronomer rather than just run open source Airflow?
That's a great question, and I think we're still trying to figure out. There are things Astronomer does which are proprietary. So an example, last year, Astronomer acquired a company called Checkin, which offers open lineage things. And most of what this company had done was open source. So there is Marcus, and they developed the open lineage protocol together with the community. But they did have a commercial product as well, which was proprietary on top of Marcus. And then Astronomer acquired that part, so Astronomer customers have access to this integrated lineage part, which is not in their open source Airflow. But even then, Astronomer pays for at least 8 employees, half of which are working on the open source side of the lineage. So there is this huge part with the community and working not necessarily with Airflow, but with Marcus and the open lineage library and toolset. Another thing Astronomer tries to do, I think, it's to improve the hosted experience. So let's say there will be a new release of Airflow. It usually has the features straight away. So let's say salary workers. I don't know how Composer is now, but in the past, all your worker nodes, if you were using salary executors, had to be of the same VM type. But Airflow does have the concept of node pools as well. And then Astronomer already supports those things. Also, authentication-wise, Astronomer has a couple of things there. Bug fixes, we would be able to fix bugs much quicker probably than other companies. And then I think the other thing is we're really trying to work now on costs. So we're really trying to optimize and allow people to pay the minimum possible. So there have been some attempts in Astronomer for us to allow people, if you don't just want to run a DAG without having the full infrastructure to be able to do that. And these parts may be proprietary. But yes, I think we're still trying to figure out a way of being viable from a financial perspective while contributing massively to open source.
Last question?
Thank you very much. Thank you, organizers.
Thank you, Tatiana. That was great. Okay. So we've got a choice now. Do we want to take a little break or we want to go straight into the next talk? Little break? Okay. Alrighty, 10 minutes break. Let's get back at 40 past. Thank you. Nice one. Cool. Okay, everyone. We about to start for talk number 2. Marty, take it away.
Thank you. G'day. So I'm here talking about using AI to automate API orchestration and data pipelines. I too have had a demo fail, so we can do right up to the Google Cloud stuff, but no Google Cloud stuff, I'm afraid, which, given the room, is probably disappointing. Or at least for half the room is disappointing. The other half don't care. Okay, so this is me. I'm Marty. I'm a software developer by trade. I work on a bunch of stuff. I work on an open source project called Taxi, which is a open source language for describing data contracts and describing API specs and kind of just describing how data and systems relate with each other. And I'm also one of the team that works on a platform called Orbital, and we're a company that automates integration between services. So we're trying to kill glue code for enterprise developers. We're really kind of focused on solving the problem for gluing together microservices or event-based architectures. We're not really kind of solving how do I connect Slack to HubSpot. We're like, how does my microservice talk to that guy's microservice in a way that's nice and lightweight? I've been building open source software for a while. I used to, a long time ago, work on a thing called Swagger Spring, which creates, it used to be called Swagger, these days it's called OpenAPI, from Spring code. So I've kind of been in the space of API specs and thinking about how we describe APIs for a while. This is what we're gonna do. So first of all, I'm gonna give a demo. Oh, so hang on, so the talk is basically, we built a cool AI thing. We think it's pretty cool. So I'm gonna show you what we built. And then I'm going to talk about how we built it, and we'll kind of break it down into the building blocks and all the different things that make it work. I'll talk about the challenges, about what worked, what didn't work, what we had to rethink. And then I'm going to do a demo again of the next iteration after we fixed a bunch of stuff. So that's 2 demos. Something will go wrong. Yeah. So, oh, hang on. One more slide. Yeah, so this is us. This is our company. Go to our website, which I should have put on the slide. But we are automating integration for microservices. So like I said, our goal is to eliminate the code that engineers write when they're stitching together services. So organizations, lots of different teams building lots of different applications, microservices, event-based architectures. We're trying to kill the code that engineers have to write that stitches my service to your service and to another one. And the reason that we do that is because every time that another service comes along, every time that I need to build another integration, it's a chunk of discovery work that I've got to do, and it's a chunk of code that I've got to write and that I've got to maintain. So when those services change, that glue code breaks. So we want to get rid of that. We want to build integration platforms that connect themselves and that automatically adapt. Most of this talk is going to be on the AI stuff that we did and kind of how it works, but we'll you'll see the other orbitally stuff along the way. So let's jump into a demo. In this demo, I am working in the high-paced world of films. So I work for a film production company, and we have a bunch of services that are running in my ecosystem. And so we have a database that has information about my films that my company has produced. We have a streaming movies provider that tells me where I can go and watch these films. Are they on Netflix, or are they on Hulu or Now TV? And we have a review service that tells me what people are saying about it. Is it any good? So these are 3 different teams, 3 different microservices, 3 different technologies. And the goal of what we're trying to do with Orbital is to make this stuff work together without having to write a bunch of glue code. And without getting too deep into it, the way that it works is that when services that we're building start up, they publish their API specs to us. So their Open API, their Swagger, their Protobuf, their whatever it is that they're using to describe their APIs, they publish them up to us with a little bit of additional semantic metadata that I'll talk about in a minute. And that just kind of describes how things fit together. So Orbital then understands that, if I click here, in our little diagram, that my films database here has a film, exposes films, but the ID from my film database can be then fed into my streaming movies provider to then tell me where people can watch it. So starting to kind of describe and explore how data and services link together. So what I want to do is start asking Orbital to do some stuff. I want to build an integration. And this is where we go into AI land. And so what we built was the ability for me to just be able to ask a question. So I can say, where can I watch Academy Dinosaur? And we run that, and it thinks, and it does a bunch of work, and come on, demo. Ah, oh, come on, demo. There we go, there we go. Now you know it's a real thing, okay. So Academy Dinosaur is up to watch on Hulu for $8.99. And the thing that's interesting about that, so we can jump into the profiler and see what we did. Dun-dun-dun-dun. So what we did was Orbital first ran a database query, so it connected to that database to look up information about films. It had to find Academy Dinosaur, and then it took the ID from that record and fed it into a microservice to go and get these fields. So one field here, title, came from our database. These other 2 fields came from our REST API, so it stitched it together. Okay, let's ask one more question, because the last one went so well. Is it any good? Do people like it? Okay, and here's some more information that we've gotten back. So Academy Dinosaur and the description that has come back, and the review score, and the review text. If we look at the profiler now, and we've had to stitch together some additional services, right? So we've got our database query, and we're still talking to the same service to get our streaming provider and name. But we got these reviews service we got our review score and information from another service. This is, we buy our reviews from a company called Squash Tomatoes. And the ID scheme that Squash Tomatoes uses is not the same as the ID scheme that we have in our database. So there's like an entity resolution problem along the way. So Orbital understands that and calls this additional service along the way to resolve the stuff. Now there's no code in the background for this. The whole point of this platform is to work out how to stitch your services together using your API specs, so you don't have to write the plumbing code. So that's what we built. That's the demo. Let me tell you about how it works. Okay, so I'm going to break this down into the different building blocks that we use in order to power that stack. So the first one is Taxi. So Taxi is an open source language and schema technology that I talked about. It's a semantic metadata and query language. So its job is to describe how data relates between systems. So we have a bunch of API spec languages out there like OpenAPI and Swagger and RAML and Protobuf and Avro, and like there's a proliferation of them, right? And they're all really good at describing one system, my system. Not so good about talking about yours, they talk about my system. And then when organizations start getting bigger and they've got lots of systems, you've got lots of OpenAPI specs floating around or whatever. But they're not very good at describing how they relate. And so that's what Taxi tries to do. It's really a way of saying this thing is the same as that thing. So for example, here's a couple of models from a couple of different domains, bounded contexts. One is a customer concept from the customer team. Another is the card concept from a card team. I've just realized, is that at Go Cardless, that might be in bad taste. And so we've got customer and model, a customer and card, two different things. And there's just like this proliferation of strings everywhere. And so what Taxi lets us do is introduce like semantic types, right? A way of saying that even though these two things are both typed as strings when they come across the wire, the bit of information that they carry is different. So I can't just swap these things around, right? They're different semantic bits of information. And we do this by adding metadata into your OpenAPI spec or your Protobuf spec or whatever. And then we can start saying that this thing is the same as that thing. So we can say that the ID field from our customer record is the same as the customer number field from the card model. We're not binding on field names because we've got different teams who want to build at their own pace. They want to name things in ways that make sense to them. But semantically, the bit of information is the same. And then we've got this API contract up here that if you pass it a customer ID, will give you a card. And so we can kind of start working out this relationship between our different specs. They're still entirely decoupled. They don't know anything about each other, but they're just sharing this semantic concept, this contract that says the ID from here can be fed into that service and give me back a card. So that's Taxi. Orbital is then the platform which takes all of those that Taxi metadata and gobbles it all up and lets us kill glue code. And that's kind of what we want to do. Like I said, we want to eliminate the integration code that engineers have to write so that they can just ship features and not plumbing. And the way that we work, so here's a kind of example query of given this customer's email address, what's their account balance? And to answer that question, we have to orchestrate together three fictional systems. We've got our customer system that's got this REST API in it with a couple of fields. We've got a SQL database. It's got another couple of fields. And we've got a SOAP API over there with another couple of fields. Nothing's named the same, 3 different protocols, 3 different systems, 3 different teams. But we stick in that Taxi metadata so we can start understanding how everything links together. So then that gets pushed up to Orbital, and Orbital can create this massive graph to understand actually how do these systems work together? How can I as a machine use your OpenAPI spec, your SOAP WSDL, your Protobuf spec to understand how the systems work? So when Orbital gets that question of given this email address, what's the account balance, it can work out through that metadata and through your OpenAPI specs and everything else that it needs to do a REST call to swap the email address for the customer ID, and then do a database query to swap the customer ID for a card number, and then do a SOAP request to go from card number to account balance to find out that Jimmy's got 29 quid. And the best part is because we didn't have to write anything, when my systems change, that can automatically adapt. You just push up your new API spec and the integrations update themselves. And we were like, man, that is a good fit for LLM, right? For OpenAI, for ChatGPT, whatever we're going to call it. This feels like a good fit. So we were kind of watching this stuff unfold, watching the space evolve, but it felt like a good fit for 2 reasons. One, ChatGPT is really good at reading code. Like you can give it an API spec and you can ask it questions. So it can understand and reason about code. It's also really good at writing code. So given we're trying to glue together these systems, it felt like a really natural place for us to start exploring. And so we did. And this is broadly the recipe of how the thing that we just built works. So first of all, and I'm going to use OpenAI and ChatGPT and LLM like completely interchangeably like everyone else. So tell ChatGPT about our systems, so give it its specs. Number 2, tell it the problem that I want solved, given this customer's email address, what's their account balance, or is Academy Dinosaur any good? ChatGPT will solve it somehow and describe back to us how to execute it. And then number 4, we interpret that response that we get back from ChatGPT and we go off and we do the execution. One of the things that's worth pointing out is, given the problem that we're trying to solve here is not how do I connect Slack to HubSpot or Stripe to, I don't know, but we're trying to connect internal systems. We can't run this on a cloud service somewhere, right? All of our stack is designed to run behind the firewall. So interpret and execute means that we run on your infrastructure rather than in some amorphous cloud somewhere. So there were some challenges in making that work. Number 1, OpenAPI is very much like the de facto standard for describing APIs, but it is verbose. Like the signal to noise ratio of that thing is low, which is a problem because these guys have limits on how much you can talk to them, right? These are the new updated limits as of a couple of weeks ago. Things got doubled. So this is, you know, by today's standards, this is luxurious, right? OpenAPI have like this hello world example of a pet store. If anyone's ever built anything in OpenAPI, you've seen it. Pet store, when encoded, is 10,000 tokens. So that's already, before you've even done any integration, it's already too big to talk to GPT-4, which is kind of where you want to be playing if you're doing any code. I've been doing some work for a customer on Spotify recently, and their API is 52,000 tokens, their OpenAPI spec. So that is too big by like 4 times to talk to these 2 systems. So that's problem number 1. Got to work out a way to solve it. Number 2 is security. Our customers don't want us sending their internal API specs up on the internet. They are uncool with that idea. And we're like, come on. And they're like, no. So we had to find a way to do this without leaking API specs up on the internet. And we haven't created our own large language model internally. So we are talking to OpenAI via the API, but we've got to be mindful of this, right? We can't just be bleeding out a whole bunch of API spec stuff. And number 3, even if we solve those first 2, we needed a way for ChatGPT to give us some information back. Like it needs to express the results. Like that demo that I showed you ran in real time, right? So we're not sending it a thing and it's giving us back some code that when we're then compiling and deploying and running through a CI/CD cycle, we've got to do it instantly. So we needed a way for ChatGPT or for someone to express back to us the way of doing that. So our first attempt went like this. We'll just send the specs to OpenAI, it'll work it out, right? We're like, that's what it does, it'll work it out. But we'll use Taxi for the specs rather than OpenAPI because it's shorter and it's more succinct. And it kind of works, right? This is the same thing expressed in OpenAPI on the right and Taxi on the left. So people don't do this. Like this is not normally how we use this internally because we love this, but like the world loves that. So people would normally take this and then embed a couple of lines in it to make it work with Taxi. But this is that just in our world, right? And it's about 80% smaller. So it kind of solves the context problem, right? The size problem. But it doesn't solve the other 2, right? We're still leaking out the specs. We're just doing it in a different format. And we haven't really solved the problem of how do we express results. So here's that example that I showed before, given this email address, what's the customer's account balance, and here's some models that are used to express that idea. And they're all nicely enriched with Taxi metadata. And it turns out that actually, this is the stuff that we care about, right? These are the nouns that describe our business. And with the way that kind of Orbital's query infrastructure works, it already has access to your API specs, so we don't need to bleed them out, right? And they've already been enriched with this Taxi metadata, so we kind of already know what a customer ID is and where I can use it. So it turns out after a bit of squinting and head scratching, really what we needed to do was take this request and tokenize it using these terms. And that ChatGPT is really, really good at, right? Like, if we want to say, take this piece of text and do some like interpretation of it and give it back to me in a different way, in a machine readable, structured way. ChatGPT is all over that. It will do that all day long. And so that's what the first version of our thing was. We're like, okay, OpenAI, you convert sentences into logic expressions. That's your job. You can use the following variables in your expressions. And then we gave it our list of types from our different specs that we've gathered up. Express the statement as a JSON that follows this contract. And so here's the statement. So what's the balance on the account for Jimmy? His email address is jimmy@foo.com. So we gave it that, and we told it to express that as a JSON thing. And then we gave it a TypeScript contract to express. And TypeScript's beautiful because it's like, I mean, it's beautiful, but it's, sorry? From a security perspective, possibly, but from a language design perspective, like it's a nice language. And it's also something that, because it's so popular, ChatGPT understands well, right? So we gave it this is the contract we gave it, nicely commented, and we said, right, express this, what is the balance of the account for Jimmy, use those variables on the previous slide, give it back to me like this, and bosh, we get that. And so it's able to kind of infer from this what the logic expression is, and now we've solved the problem of how do I get it in a way that I can understand it. And so then we take this object and we wrote an interpreter for that to then plug into our big graph thing that we've got, and we can work out that Jimmy's got 23 quid. And so that's kind of how it works. And that's what powered the demo that I just showed you guys. That's kind of soup to nuts how it works. Woo! Hey! Hey! So it worked for a bit, and there were some challenges with it, right? So it worked fine for simple predicates, because that's the contract that we had given ChatGPT for expressing simple Boolean conditions, right? But Taxi is a query language, and Orbital as an integration engine can do some really cool stuff. And all of a sudden, like when we started trying to replay some of the integrations we'd shipped, like we couldn't build them using that infrastructure. Like we had no way of expressing calculations or derived relationships between fields. We had no way of, like Orbital knows how to go and fill in missing data if you need it to. It will go and find a way to fill it in. It knows how to resolve entities like we saw. It knows how to combine and stitch fields together. And we had no way, that construct that we had no way of doing this. And this is really complex. Like we spent years working on Taxi to get nice ways of expressing this stuff. We didn't really want to do it again in JSON because the whole point of Taxi is that it's not JSON. Yeah, and we're not leaking those. We don't want to leak those database connections out, right? Like we want to keep everything running in your infrastructure behind your secure firewalls and your nice tied down ecosystem. So plan B, teach ChatGPT how to write Taxi. And we were really kind of freaked out about this because we did a bunch of research on embeddings and fine tunings and all of the like kind of more advanced stuff. Got a little bit nervous, and it turns out we didn't need to. Because our token count is so low, and because the token numbers had been bumped up, we can just one-shot this. We literally teach ChatGPT how to write Taxi, and we inline in the message. We just embed it. So we teach it the rules. We say, right, you've got a new job. You convert sentences into Taxi queries, and this is how you write Taxi. And then we gave it a bunch of examples, and we do this on every query. And we're like, right, here's how you do it. And if they want to do this, here's some examples. And if they want to do that, here's some examples. And then here's the types that you can use. And then what's the balance on the account for Jimmy? His email address is jimmy@foo.com. And we get back that. And that's a Taxi query for finding a customer with an email address of jimmy@foo.com and returning a field called balance with a type of account balance. And we taught ChatGPT how to do that. And it worked. It works. Hooray! It kind of works. And it kind of worked eventually. We had to round trip it a few times, and this is the part that we're still working on. So it kind of works. It works more often than it fails, but there are limitations. And like one of the challenges is as the number of API specs grow and as the taxonomy gets richer and richer, we're going to start running out of space to teach it taxi. So we are starting to look into how do we fine tune LLMs for taxi. Right, demo on the advanced stuff. I actually need a minute to switch over to the more advanced deployment. So does anyone have a question while I'm deploying? Yep. Sorry. We can join across multiple systems, join across multiple tables. Is that what you're asking? Can we test the same way? So you can download you can run those queries and turn them into unit tests if that's what you're asking, but I feel like you're asking something else. Yep, okay, cool. Right, give me 1 sec. I should probably turn this off, but no one looked too close. Yeah, good. Yep. Yep. So there's a couple of things. So I'll just repeat the question. Basically, the question is, who gets to decide the meaning of the semantics, right? Because if you are trying to do this cross-team, then it starts to get really tricky. And there's a couple of answers to that. First of all, you only do this with scalar types, right? So you don't do this with models. And it turns out it's much easier to agree on the definition of a scalar type on a customer ID than it is to agree on the shape of a customer, because it's much less contentious for us to say that a customer ID is a string, right? And so because we're not trying to define entities, we're just trying to define concepts or nouns that exist in our business, it becomes less contentious. The second part to that question is, who gets to define it? I mean, that's broadly an organizational question, but the reality is that the relationship... Well, it depends, right? It depends on what there's no regulators in my movie business. So in my movie business, we got to pick the types ourselves. And the reality is, regardless of who defines it, the business has already picked those names. Like they're already the terms that you're using. And if you think about the way that you build that integration today, you kind of sit down, you look at 2 API specs, you go, this thing and that thing are the same thing, and then you wire it up, you forget about it, you go to the pub, and the next person who comes along does the same thing. The reality is that the semantics are already there. We're just really shit at writing them down. And so Taxi's just trying to give us a way to capture it. And then all the questions about the organizational politics around how, we're just a tech company. Well, okay, so that actually leads to another point, which is that if your customer ID and my customer ID are not the same, like we saw with Film ID into the review service, right? My Film ID and Squash Tomatoes Film ID ain't the same thing. Therefore, semantically, they cannot have the same contract. So you need to give them a different semantic type. So the semantic contract becomes really important, as it already is in our organization. If I try and feed one ID into the wrong place, stuff doesn't work. And it doesn't matter if I code that or if some AI works out how to do it, right? So the semantics are really good. But we are actually working on, right now, looking at traffic and going, okay, we think these 2 things are the same, and tell us if we're wrong. So we're working on that, but that one's much harder. Okay. Oh, man. One more question. Anyone? Yeah. Oh, no, seriously. This is going to work. This is going to work. Have we looked into training our own models? So Orbital runs in your infrastructure. So everything that's running in Orbital is running on your firewall, and the only thing that's going out are the nouns, so customer ID. So sorry, the nouns and the question. So yep, it is still a little bit leaky, and I think the nouns are probably less contentious. Like no one's going to infer a huge amount from the fact that you have a customer ID somewhere in your system. But the questions going out depends a little bit on, to your point, on like which area you're in. If you're a bank, you're not sending out like your trade questions out to the internet to get them classified. But if you're in a films company and you want to know if Academy Dinosaur's any good, fine, like whatever. Come on. Oh, this demo is really cool. Okay, we're going to try this one more time. Any more questions? Yep, sorry.
Could you briefly, if possible, explain like the integration or onboarding process, something like Orbital? Like if I'm an organization who currently manages all my services together, like when I enter an agreement with you, what's the sort of process?
Yeah, so the question is, what's the onboarding process look like? Oh man, this isn't going to work. What's the onboarding process look like? So Orbital runs in your infrastructure. So you spin up the Docker image, you deploy it on your Kubernetes cluster somewhere. And you do it incrementally, right? So you don't do this big bang, we are now an Orbital shop. Normally what happens is there's a team that like cool stuff. And so they deploy it across a couple of microservices. And all they do is they annotate their API specs. And then that gives their teams the ability to start sending queries without having to build the integration code. And then that gets bigger and gets bigger. So you kind of roll it out incrementally. Orbital is kind of designed around this philosophy of everything being Git-based. So it doesn't have a database. So everything just lives in a Git repo. So it kind of works really nicely for like all your API specs and all the taxi configuration, and everything just lives in a Git repo. So it's really nice for kind of Git-based collaboration and pull requests around this stuff. Okay, this demo is not going to work, and it is getting late, and that's really disappointing. I'll answer any more questions while I try and get it up. Yep, up the back. Okay, so I'll just repeat. Did everyone hear the question? I'll repeat the question. It's basically how big are we trying to take this, right? Like integration is huge. Do we want to try and address integration? I mean, like broadly speaking, yeah. I don't really want to put 1 million people out of a job. I mean, I can't even get my second demo to run. But like we don't want to. We're not trying to do that. But yeah, integration sucks, right? Like it is dumb work of plumbing together systems that we already wrote a spec that was designed for a computer to read, that then a human reads to plumb it to another computer that also has a spec that is designed for a computer to read. Like it is dumb. This is how like computers beat us. They are literally getting us to wire their software together. So yeah, we think that's dumb, and we want to get to a point where like we can already do some relatively advanced integrations, but we want to get to a point where engineers don't need to write integration code. There's a massive kind of onus shift when you start thinking about this, which is that the teams that build software become really responsible for writing good API specs that design it, because the goal is, at the moment, the consumers of those APIs are kind of polyfilling their shitty documentation with work. And so we want to move that back into the producers because it's where the work belongs. But once that's done, yeah, we don't want anyone writing integration code. Yeah. Oh, it'll be fine. Any other questions? Yeah.
Yeah, a question about the verification of AI. I've tried a lot of things like factor dependent or something. The relevant can use that.
Yeah, cool. So the question is, have we explored the use of things like vector databases to alleviate the context window problems that we've got that I was talking about? We haven't. We will. Vector databases are a natural place for us to store the things that don't change frequently in your organization, like the nouns, right? It's also, and then a well-tuned model is a natural place for us to solve the problem of teaching ChatGPT how to write taxi on every single query. So those are the two areas of research that we're playing with at the moment. So then you can get, kind of significantly more complex stuff. Yeah. Yep. Okay, so integration testing is really interesting. Why is this thing not working? Integration testing is really interesting, right? So at the moment, when we think about integration testing, we generally test that the systems sent the data that we care about between them, which is like a really brittle way to design our integration tests, because the whole point of everything else that we're doing in our organization is to make change rapid, right? And so then we write these tests to make sure that nothing changed, which is kind of nuts. So with Orbital, you can download your queries as a test that you can run, and it will tell you, it's focused on a slightly different thing. It's like, okay, did we speak to the same systems? Is the input and the output the same? If the execution path has changed, we'll tell you about it, but we don't consider that a failure, because that's kind of the job of the dev team, is to change the stuff at pace. So we'll tell you about it, but we don't consider it a failure. I don't know, the second demo is not going to work. Yeah. I gave it a good go. In the second demo, we would have seen it filling in missing data. We would have seen it computing information on the fly, calculating an ESG score for anyone who does finance in the room, looking up stuff and doing a bunch of really complex entity resolution. It was a really cool second demo. Thank you.
Cool. Thank you anyway. We appreciate. We know that is complicated stuff, so no worries. We have got time for maybe the last questions, and then we off to the raffle. Yes, a couple. 1, 2.
What's the future of microservices architectures? Or not, let me rephrase the question again. What are the futures for distributed monoliths on Java in place of microservices architectures?
I have opinions about that. So the question is, what's the future of distributed monoliths written in Java? I have opinions about that, but that's not really the talk. I think that distributed systems are the way that teams are going to continue to go. I think that there's been some very high-profile stuff recently about people moving from lambdas to microservices and microservices to lambdas, and really I feel like a lot of that is just about squabbling about size, right? But I do think systems are more and more likely to be distributed. I think that CTOs, CIOs are looking to outsource or buy rather than build, so there's a massive integration challenge continuing on the space. Developers are looking for smaller units of deployment so they can build and ship more frequently. I think that things are going to continue to be distributed, but I also think, as with anything, we're going to get better at deciding what the right size of a deployment thing is.
Last one over there.
Hey, so I've seen that you've worked on OpenAI a lot. Great stuff. Open API, rather. But it seems like a couple of the main reasons for writing your own language in Taxi is to make it smaller and kind of define models and define methods. I'm wondering, is there a good reason that you didn't go with something like gRPC that basically does exactly that, that's already established in a place? And another slightly unrelated question, does this have the potential to kind of replace Fivetran and Tray.io and other such things?
Thanks. Okay, 2 questions. Why didn't we use gRPC? gRPC is cool. Really like it. Protobuf, cool. Really like it. One of the main reasons that we didn't is because we're trying to solve for distributed teams that are polyglot by nature, right? So you get into an enterprise, lots of teams are building in lots of different technology. And I think it's the same problem that GraphQL has, right? It's kind of a shitty thing to say, I will work with your service, but you got to take my tech stack for that to work. So we kind of, as a philosophy, we want to meet developers in the tech stacks that they're building in. So we didn't adopt gRPC and we didn't adopt protobufs because it would exclude the people that are building on RAML or who are building on Avro or who are building on GraphQL or who are building on OpenAPI. For the same reason that originally when I started this, like Taxi, the first few versions of Taxi were really just like a protest against what I felt about OpenAPI, right? Or Swagger at the time. But like the intent of Taxi isn't for people to ditch Swagger or OpenAPI, it's for them to polyfill the things that those schemas don't do well. gRPC, protobuf, last time I checked, you can't do type aliased semantic scalars, so you have no, and I might be wrong, but you have, at the time, you have no way of expressing the semantic contracts that traverse systems. So that was why we didn't go for it. Are we trying to replace Fivetran? And well, yes and no. I think that if you are wanting to get your HubSpot data into your data lake, into Snowflake, we're not going to try and solve that problem because I think that Airbyte is going to cannibalize the market, right? I mean, they're just going to open source everything. It's going to be a race to the bottom. What we're more interested in solving for is reducing the need for teams to build data pipelines and integrations that are dumb. Right? So it's more likely that we're going to be going after the DBTs of the world, where you're building integrations that are just mapping one field from one system to the same field in another system. We think a lot of that stuff can be automated, and we think that the engineers who are building that stuff right now are better off solving hard, interesting problems that are not mapping fields from one system to another. Cool. Thank you very much. Thank you.
Thank you, Martin.